Good afternoon everyone, I am Asthalutari from MTech IT 4th SAM and today we will discuss question number 2 of lab assignment 2. So our question is to write Python code for applying interpolation using first Lagrange's interpolation, second Hermite interpolation, third divided difference table and fourth difference table. First we will discuss the Python program for Lagrange's interpolation. Def Lagrange interpolation, we will make a function named Lagrange interpolation x, y and xp. N is equals to len x, yp is equals to 0. Now we will use for loop for I in range n, p is equals to 1 and for j in range n if I is not equal to j. P is equals to xp minus xj upon xi minus xj. Yp plus is equals to p into yi and then at last return yp. Next we will discuss Hermite interpolation. First we will make a function that is Hermite interpolation, def Hermite interpolation x, y, dy and xp. N is equals to len x, z is equals to 0 into 2 into n, q is equals to 0 for I in range 2 into n and for I in range 2 into n. For I in range n, z is z, 2 into I is equals to z, 2 into I plus 1 is equals to xi, q 2 into I 0 is equals to 2, q 2 into I plus 1 into 0 is equals to yi, q 2 into I plus 1 into 1 is equals to dyi, q 2 into I into 1 is equals to q 2 into I 0 minus q 2 into I minus 1 0 upon z 2 into I minus z 2 into I minus 1 if I is not equal to 0 else print dyi. Now we will take the for loop for I in range 2 to 2 into n and for j in range 2 to I plus 1. Qij is equals to Qij minus 1 minus Qi minus 1 j minus 1 upon zi minus zi minus j. Result is equals to q into 0 into 0 for I in range 1 to 2 into n. Term is equals to q into I. For j in range I, term into is equals to xp minus zj. Result plus is equals to term and at last returns result. And next is divided difference table, that is Newton divided difference. First we will make a function def divided difference xy. N is equals to len x, coefficient is equals to 0 for I in range n and for dash in range n. First for I in range n, coefficient I and 0 is equals to yi. For j in range 1 n, for I in range n minus j, coefficient ij is equals to coefficient I plus 1 j minus 1 minus coefficient I j minus 1 upon x I plus j minus I into xi. Return coefficient 0 I for I in range n. Now we will make another function that is def Newton divided difference xy and xp. Coefficient is equals to divided difference xy. N is equals to len x. Result is equals to coefficient 0 for I in range 1 n. Term coefficients I. For j in range I, term is equals to xp minus xj. Result plus is equals to term, return result. And at last we will discuss difference table, that is forward difference. First we will make a function that is def forward difference table xy. N is equals to len y. Difference table is equals to y dot copy. Here we are using copy constructor. For I in range 1 to n, previous is equals to difference table minus 1 and current is equals to previous j plus 1 minus previous j. For j in range L, len previous minus 1, difference table dot append current. Return difference table. Def Newton forward interpolation x, y and xp. H is equals to x1 minus x0 and difference table is equals to forward difference table x and y. N is equals to len x. U is equals to xp minus x0 upon h. Result is equals to y0. U underscore term is equals to 1. For I in range 1 n, u term is equals to u minus I plus 1 upon I. result is equals to u term into difference table I0 and at last return result. Thank you so much for listening.